Hello everyone, welcome to Olsen Cafe. Now in my last video, I have covered all that you must know on circle properties. If you have not watched that video yet, do remember to check it out. I have included the link in the description below. In this lesson, I will be focusing on practicing the skill of identifying the properties. To me, this is the most important step which is often neglected when it comes to solving questions on circle properties. If you do this well, you will be able to solve more efficiently. Okay, let's dive into the lesson now. Okay, so here is the problem. The objective of this lesson is to help you to see the properties better and also to sieve out certain misconceptions. Now, the common mistake by those who are struggling with this topic, it is simply to jump into solving the question without understanding the diagram. And this often leads to the misinterpretation of the properties and apply them incorrectly or to give the wrong reason for the answer. So let's practice the skill of identifying the properties right now. Let's move on to understanding the diagram now. So one question that I often like to ask is, what do you see? So in the process of what do you see, do go through some of the properties that you already learned in my previous video. So in the process, try to list as many properties as possible. So go through systematically. So in this case, you can start off with angles in the same segment. So with this, right, you will be able to see some of the common chords. So you can see these are some of the angles that has angles in the same segment. So if we start with the first one with angle EAD, so what you have here is you have this ED as common. So you can see I have ED here. All right, it's a common chord. So we have the ED, then therefore I am able to see that this angle here, angle EAD, and you can see the butterfly. So this angle EAD is equals to angle EBD. Then likewise, if you move on to the next angle, which is with AB as a chord, so again, you can see the common letters, so AB. So you have AB as a chord. So now, right now, you have this as AB as a common chord. So with this, then you are able to identify the two angles. So you have angle ADB. This is equals to angle AEB. So as you can see from my angle here, I have another one that is angle ABE. So I have AE here as a common chord. So AE now, which is this chord here, AE. This is my common chord. So right now I am actually dealing with this angle B, which is this one here, 62 degrees, which is this. This is equals to angle ADE. So this is with angles in the same segment. Now we move on to the next property. So the next property that we see here, all right, is angles in the opposite segment. So with angles in opposite segment, so right now, if you've understood my previous video, right? So you notice, you will know that I will need to identify cyclic chord. So how many cyclic chord do you see from here? So in this case, you will see the first cyclic chord. In this case, the first cyclic chord is angle BCD. So that means you are having this one here. Let me highlight the cyclic chord. So this is the first cyclic chord that you see. So this one is A, B, C, D. So this is a first cyclic chord. So the first cyclic chord will give you angle C, the two opposite angles that are supplementary. So you have these two, and then similarly, you have the other opposite angles, which is angle ADC and angle ABC. So this is the first pair of the supplementary angles. Then the next one that you will see will be another cyclic chord. So this another cyclic chord, what you have here is in this particular one, so which is your A, B, D, E, which is this one here. So in this case, what you have is angle ABD, plus angle AED. This is supplementary. And then you have the other pair of opposite angles, which is also supplementary. Yeah, so this is angles in the opposite segment. So what else do you see, all right, from this diagram here beside the other two properties? Yeah, so again, we list out as many as we can. So over here that we have here is right angle in semicircle. So to identify right angle in semicircle, what is important is you must be able to see the diameter. So which is the diameter in this case? All right, so the diameter in this case is actually BE. Yeah, so you will know that BE will pass through the center O. Yeah, in this case, even though it never state here. So with this diameter, so I will know that this angle BAD is 90 degrees, and likewise angle BDE is also 90 degrees. Yeah, so with right angle in a semicircle, so what else do we see? So not sure if you're able to see that BE is parallel to DC. So in this case, it is not difficult to see that. In fact, the question already tells you that these two are parallel. Now, with these two are parallel, right, what you are should be able to identify is the interior angle. So where is the interior angle in this case? So the interior angles that you have here, all right, will be this, because these two are parallel, isn't it? So if these two are parallel, you can see a letter C here, so which means this angle, all right, angle CBF and angle BCD, these two angles add up must be equal to 180. That's interior angles. And you also have alternate angles. So alternate angle, which is, you can see here, this angle, all right, is actually the same as this angle here. So we do have alternate angles. Now there is another property that is very seldom used, all right, by students, which I find it is actually very useful. It is for you guys to identify exterior angle of a triangle. This is something whereby a property whereby you actually learn in primary school. So which angle are we referring to over here? The exterior angle of a triangle. So I'm actually referring to this angle, angle F. Yeah, so with this angle F, hopefully you are able to see the triangle. This is known as the exterior angle of a triangle. So you can see the triangle that I'm looking out for is this one. Okay, so with this property, right, in primary school, you actually learn that this exterior angle, which is angle F over here, it is actually the same, it's the sum of these two angles here, so which is this one angle A, this is your angle B. So these two angles, you add up together, will give you this exterior angle F. So angle A and B are known as the interior angle, and this is the exterior angle. And this is a particular property which I find it very useful, which is not able to apply by many students. Over here in these slides, I would like to go through some of the common misconceptions on this question, now that we have almost identified all the properties that we can see in the diagram. Now, so the question that I would like to pose to you is angle ADB 90 degrees? So which means I'm referring to angle ABD here. Now, so do take note, if angle ABD is 90 degrees, then the condition that must be fulfilled is that AD has to be the diameter, so that we can apply right angle in the semicircle. So therefore the question will be, is AD a diameter? And then is point F the center? Because I think earlier on we learned that a diameter must always pass through the center, isn't it? So over here what we have is AD pass through the point F. So the question now is F the center of the circle, which is often being misinterpreted. Yeah, so if you understood this diagram carefully, right, we will know that this point here where my laser is, this is a center. So therefore the question is F the center? So on the similar note, then the question will be, is angle AED, which is this angle here, is this angle is 90 degrees? Yeah, so again, if this is 90 degrees, provided AD is the diameter. So therefore the question that we have to ask ourselves is AD the diameter. Yeah, so over here, so therefore, do take note. Yeah, we can see from here, right, as I explained earlier on, AD, obviously it is not the diameter. Why? Because F is not the center. The center is actually at this point here. Yeah, so F is not the center of the circle. And the other misconception, it is actually BFDC. So take note, BFDC is not a cyclic chord. So this is often being misinterpreted. Why? Yeah, because point F, it is not on the circumference of the circle. So that is why BFDC is not a cyclic chord. Now, so with all this understanding, right, we are ready to start to solve the questions over here already. So what we do have now, right, as we can see, all right, to find angle ADE. So when we look at this, to find angle ADE, what is angle ADE? ADE that we have earlier on. All right, we know that this ADE, it is actually the same as angle ABE. So this is actually equals to 62 degrees. Reason for this is angles in the same segment. Now, similarly, if we look at angle AEB, so if we look at angle AEB now, AEB is this one here. So if you have identified the properties in my previous slides, right, then you will know that this angle here, all right, I can easily solve by using right angle in the semicircle, because we already know the angle BAE is 90 degrees. So therefore, to get angle AEB, this is simply, all right, by using 90 degrees minus of 62, and this will give me this answer as 28 degrees. All right, so this is simply 28 degrees. Reason, right angle in a semicircle. Now we move on to angle BAD. Now for angle BAD, which is what you will see here, angle BAD, which is this one here. So based on this, as we have identified earlier on, there is a cyclic chord. So this cyclic chord is simply A, B, C, and D. So since this is a cyclic chord, so therefore what I know is this angle BAD together with angle BCD, these two angles are supplementary. So with this, right, 180 degrees minus a 110, so therefore I know that this angle is equals to 70 degrees. Yeah, so this is quite easily done for part 1. Yep, so we move on to part 2. Now, as part 2, you will notice that because early on we have already done the groundwork. Yeah, so once we have done the groundwork, right, to do part 2, it is actually not that tough now. So if you look at angle BFD, as I mentioned earlier on, right, we can actually make use of exterior angle of a triangle, which is what we have here, because to find BFD, it is referring to this angle here. So early on, I have already showed you. So this angle, it is actually equals to the sum of these two. All right, the sum of angle A and angle B. So putting this together, so I know that angle BFD, it is actually 62 degrees plus 70 degrees. So the reason that I write down will be exterior angle of a triangle. So this can be easily done, 132 degrees. Now moving on, then we find the last part, which is angle DBC. Now to find angle DBC, all right, let's take a look at what do we have. So angle DBC that we have here, right? So this is the angle that we need to find, angle DBC, which is this one here. Okay, so to find this, right, you notice in my earlier part, I have already identified for you, right, because I know that these two lines are parallel. Okay, these are parallel. So therefore, if I look at the angle, letter C, so I know that I can easily make use of interior angle of this with these two parallel lines. So by doing this, right, so what I have here is I'm able to find angle EAD, all right, and angle EAD, which is this one here. This is equals to 20 degrees because I know that this angle A here is 70 degrees. So the whole angle BAE is 90, which is what we have earlier on. So 90 minus of 70. So therefore, I am able to get this angle as 20 degrees. So if this is 20 degrees, I'm able to also know that this angle here, is shaded here, this angle here, it is also equals to 20 degrees. All right, simply angles in the same segment. So all this I have done the groundwork by identifying the properties at the start. So applying all this together, right? So I will be able to find angle DBC is equals to 180 minus of 20 minus of 110, which is equals to 50 degrees. So the reason that we give it is interior angle, then I quote BE parallel to DC. So with this, all right, the whole entire question is done. Yeah. Now, so therefore, I hope you find this approach to solving the question is useful. I strongly encourage all of you to give it a try. Don't skip this step. Yeah, with practice, you will definitely get better at it. And this can be done in very, very short time, in less than a minute, or sometimes even only 30 seconds. I'm a strong believer of wasting time at the start so that you can save time later on. Once you master this skill, right, you can easily check, you can solve any question easily. Yeah, so with this, I'm done with this lesson here. You can check out my next video on solving problems involving tangent. All right, I see you there. Bye.